Hello everyone, we are back with another paper today. Today we're officially starting the October-November 2024 series. The papers are actually up on the page. All the papers for physics, chemistry, math and biology are up. They've been uploaded, so feel free to download them and solve them. And I'll be launching October-November 2024 papers exclusively starting from today. The upload date is actually going to be 10th January. And yeah, we'll be launching papers every day of the week. We'll be starting with math P1, M1, S1, P3, followed by physics, chemistry, bio paper 1, then more paper 2, paper 4 and paper 5. So hopefully I'll be done uploading all of them by the end of February. So look forward to that. And we have great news. We are actually launching, or we have actually launched the first physical location for CI paper solved. The Google Maps location is given here. It is located at Dhanmondi, Dhaka, Road 5. My WhatsApp number is also given here. This is the official business number, so please feel free to contact me if you have any queries. You can buy notes from me. You can join the mock exams, or you can join the crash course or revision batch, which is essentially a crash course of 3 months duration. It's a monthly subscription. A2 batches is like 3 classes weekly, so it's 6,000 BDT or 50 USD monthly, and the AS classes are 42 USD or 5,000 BDT only monthly. So the crash course will basically compress the syllabus in a short amount of time, cover the clear concepts, cover the concepts and clarify them for you. And we'll be solving question papers as well from the recent years, and we'll be solving the problems in general. So it should be enough if you haven't read much, honestly, for the first 6 to 7 months. This 3 months course should be enough to get you an A if you attend regularly. So if you're a student from Bangladesh, please feel free to join physically. The classes will be hybrid though, online and offline simultaneously, and you will be provided access to the recordings if you've missed the classes for a long time, at least till your exams end. So that's not an issue. Access will not expire. And if you're an international student, please feel free to join as well. We'll be having separate batches for international students. Classes will be in English completely, so no worries about that. So yeah, hoping to see a lot of you from February. And I have great news as well. We are actually gonna do an iPhone 16 giveaway sometime soon, whenever the channel reaches 25k subscribers. As a gift to my subscribers, I'm thankful to all of you for supporting me. So yeah, feel free to contact me. The mocks will also be great because I've handpicked the questions, the hard questions from the recent years. So yeah, just feel free to join. These mocks will also be amazing. If you do all the mocks, there will be around 10 to 12 mocks for each subject. You'll be covering all the key questions, and you'll be given access to solution classes. You can attend them physically or online, and you'll be given access to the recordings of the solution classes as well. So feel free to join, because if you're an international student, you can get access to the answer key as well as the question paper. And trust me, these are worth it. You will get premium service, so do not miss out. Seats are limited. And the new location is huge. It's a huge area, so hoping to see a lot of you very soon. Anyway, let's start with the paper. Let's not waste any more time. So before we begin, with what paper is this? This is 9709 paper 1-2 from the October-November 2024 series. 1 hour 50 minutes is the time, and it's from pure math paper 1. Okay, so let's take a look at the threshold. We are actually solving this paper, component 1-2. So as you can see, A was at 52. It's a relatively difficult paper, right? A was at 52, B was at 44. So let's write that down. So out of 75, A was at 52, B was at 44, C was at 34, D was at 24, and E was at 15. So as you can see, there's a gap of about 10 marks. Okay, 10 to 8 marks. So A star should be somewhere around 60 or 62, logically. Around 60 to 62. Okay, so let's start the paper. And if you like the content, please remember to subscribe to the channel. It helps with the algorithm a lot. A lot of you haven't subscribed yet, which is fine. But if you do, it's going to be really helpful for me. And remember to like the video. So give non-exact numerical answers correct to 3SF or 1 dp for angles in degrees, unless a different level of accuracy is specified. Okay, 75 marks is the total, marks allotted, and you will be given access to MF90 in the formula sheet. All right. So let's begin. The diagram shows the curve with equation y is equal to a sine bx plus c. All right. From 0 to 2 pi, where a, b, and c are positive constants, state the values of a, b, and c. Fine. So the main goal is to find the equilibrium line, which is this 3. Okay. So this is essentially this c. It's 3. Next, find out the amplitude. How much is the amplitude? It goes from 3 to 7, which is 4. Okay. So the amplitude is 4. A is 4. All right. That's also great. So we now know that A is 4 and C is 3. And what about B? So typically speaking, a sine curve is supposed to complete its revolution in 2 pi radians. But here, it actually completes its revolution in pi radians. Okay. So the period is half, or the frequency is basically double. So how do you do this actually? How to find out B? So B will essentially be 360 degree or 2 pi divided by the time period for, or the angles taken for one complete revolution, which is pi. So if you get rid of this, what do we get? B is equal to 2. Okay. So the 2 pi will be fixed, and the one in the denominator will be the radians taken for one complete revolution, essentially. Okay. Next, for these values of a, b, and c. So what is the final answer? It is basically 4 sine twice x plus 3. Okay. For these values of a, b, and c, determine the number of solutions in the interval 0 to 2 pi for each of the following equations. Okay. Is equal to 7 minus x. So let's do that. 7 minus x. So 7 minus x. So it will start from 7. It's best to draw here. Okay. 7 minus x. So y is equal to 7 minus x. So when is x is equal to 0, y is equal to 7. And let's find out the other one. It's a straight line with negative gradients. So when y is equal to 0, x is also equal to 7. Okay. So where does 7 lie on this? So we know that 2 pi is basically 6.28, right? So 7 should be somewhere over here. 7 should be somewhere over here, essentially. Because 3 by 2 pi, how much is that? That's 4.71. This is 4.71. Okay. So this is 5.5. Okay. So the general idea is, why don't we find another point? Okay, why don't we just input another value and then we can draw a straight line? Okay, when we know that when x is 0, y is 7, why don't we input pi? Why don't we input pi and see the value of y? So y is equal to 7 minus pi. How much is that? 7 minus pi. That's 3.85. 3.86 actually. 3.86. So when it's pi, it's 3.86. It should go through here. And let's apply 2 pi then. Y is equal to 7 minus 2 pi. How much is it? 7 minus 2 pi. That's actually 0.72. When it's 2 pi, it's 0.72. So somewhere over here, basically. Okay, so let's draw a straight line now, shall we? So it's basically like this. Okay, it goes like this, basically, something like this. Okay, so how many solutions do we have then? We have 1, 2, 3, 4, 5 solutions, because it's gonna go down, so it's not gonna intersect it anymore. So 5 solutions. And then what about this? 2 pi x minus 1. 2 pi x minus 1. So let's do the math. when x is equal to 0, y is equal to 2 pi into minus 1, which is minus 2 pi. When x is equal to 0, y is equal to minus 2 pi, and minus 2 pi is basically 6.28 minus 6.28. It starts from down below, minus 6.28, minus 2, minus 3, so down below. Okay, so that's not really important. That's not important actually. Let's try some other values. Okay, like why don't we try pi by 2? Okay, so x equals to pi by 2, or another important value should be, okay, fine, it's okay. So y is equal to 2 pi into pi by 2 minus 1. So pi by 2 minus 1 into 2 pi, how much is that? 3.58. At pi by 2 it's 3.58. At pi by 2 it's 3.58. so where is that? 3.58 is somewhere over here. So why don't we try this pi by 4, then we will get a good idea. X equals to pi by 4, y is equal to 2 pi by 4 minus 1, pi by 4 minus 1 into 2 pi, that is minus 1.3. okay, so here it's minus 1.3 actually, somewhere over here. So basically if we draw this now, I'm going to use orange for this line. It's basically like this, kind of like this. Wait, so yeah, it's like this. So as you can see, it will only intersect the graph once. Wait, let me fix it up. Goes through here. Yeah, so it actually intersects the graph once over here, just behind pi by 2, and so we should only have one solution. So do you guys get that, how we did it? Okay, next, number 2. The first term of an arithmetic progression is minus 20 and the common difference is 5 plus 5. Find the sum of the first two terms. Okay, a is equal to minus 20 and the common difference is plus 5. So Sn is equal to n by 2, 2a plus n minus 1 d. Okay, so S20 is equal to 20 by 2, 2 times minus 20 plus n minus 1, which is 19 times 5. okay, so 2 into minus 20 plus 19 into 5 into 10, which is 550, right? So I just applied this from the formula booklet, MF19. You guys will have access to that. Okay, no worries, you have access to the formula booklet. And if you're wondering where it is, the formula is just given over here. Sorry, here, I'll just use this. Okay, cool. Okay, it is given that the sum of the first two k terms is 10 times the sum of the first k terms. Okay, so sum of the first two k terms is equal to 10 times the sum of the first k terms. Okay, so let's do this. 2k divided by n, so 2a plus n minus 1 d is equal to 10 times k divided by n, 2a plus n minus 1 d. But the difference here is you gotta change the number of terms. For this one it should be 2k terms, and for this one it should be k terms. This is the logic. Okay, so we can get rid of a few things on both sides, like we can get rid of this n. So let's do the math then. 2k, 2 times minus 20 plus 2k minus 1 into d, it's d5, is equal to 10k. okay, 2 into minus 20 again, plus k minus 1 into 5. Fine. Oh, we can also get rid of k. We can get rid of k like this. Fine. And we can actually reduce this 2 and 5, you know, like we can get rid of we can put the 2 on the right hand side. 10 by 2 is 5. Okay, so we actually get over here minus 40 plus 10k minus 5 is equal to 10 by 2 minus 40 plus 5k minus 5. okay, so minus 45 plus 10k is equal to 5. Again minus 45 plus 5k. Minus 45 plus 10k is equal to 5 into minus 45, which is minus 225 plus 25k. So ultimately, minus 45 plus 225, which is 180 on the left hand side, is equal to 15k. So 180 by 15, that gives us a value of k is equal to 12, and that should be the answer. And yeah, it matches with the mark scheme. Let's go to question number 3. The equation for curve is y is equal to 2x square minus 3. 2 points a and b with x coordinates 2 and 2 plus h respectively lie on the curve. Find and simplify an expression for the gradient of chord AB in terms of h. Okay, 2 points a and b. Okay, so MAB. Oh, we gotta find out the coordinates first, yeah? So y is equal to 2 square minus 3, which is 8 minus 2, which is 5. So basically it's 2 and 5. And on the other hand, it's y is equal to 2 times 2 plus 2 plus h whole square minus 3. Okay. Y is equal to 2. So that's 4 plus 4h plus h square minus 3. That's actually 8 plus 8h plus 2h square minus 3, which is 5 plus 8h plus 2h square. Okay, so these are our coordinates, 2 plus h, and over here 5 plus 8h plus 2h square. So now we have to find out the gradient of chord AB. So that's 5 plus 8h plus 2h square minus 5 divided by 2 plus h minus 2. Fine. So we actually end up with 8h plus 2h square divided by h. Then we can take h common. 8 plus 2h divided by h. That is, yeah, that is it. So MAB of the chord is 8 plus 2h, or so it seems. Okay, good. Explain how the gradient of the curve at point A can be deduced from the answer to part A. So what you need to understand, the chord AB of this curve is essentially a tangent, right? Suppose this is a curve A and B. So when you basically find out the chord, okay, so essentially it is the tangent at A. Okay, it's essentially the tangent at A, or it's basically a straight line or tangent. So essentially if you differentiate this, okay, if you differentiate this, then you are going to get the gradient. All right, so you basically need to state this. You need to state that the chord AB is essentially the tangent at A. So the chord AB is the tangent at A. It's a straight line. We found out the tangent at A, and we know that the gradient of this line can be deduced. The gradient of the curve. The gradient of the curve is basically, look, the differentiation of this. Look, dy by dx is going to be 4x, right? And you need to understand that the chord AB, okay, so you guys get it, right? The chord at AB is basically the tangent at A. So we know that the logic of finding the gradient is dy by dx of the curve, the first differential. So we can input the coordinate, x coordinate of A here, which is 2, because it is at A. So look, dy by dx will be 4 times 2, which is 8. That is the answer. Okay, so this is the logic. So you essentially need to state that the chord at AB is actually the tangent at A. Okay, so yeah, when you just apply that, you actually end up with 8. Okay, that's the logic. Number 4, find the term independent of x in the expansion of this. Fine. Okay, I actually do it manually, which is basically x to the power 6 plus 6c1, x to the power 5, 3 by x square, plus 6c2, x to the power 4 times 3 by x square whole square. So this is the term where it cancels out. So it's basically 6c2 times 3 square, because we get rid of the x's, right? 6c2 times 3 square. We should only get rid of x's. There's no point keeping x's. So that's 135. Okay, that is our answer. Next, all right, so 4x cube minus 5 times this 6 to the power x to the power 6 plus 6c1, x to the power 5. Okay, and 3 by x square plus 6c2. Oh, we know the value, right? This is going to be 135, just 135, and that should be it. And then we need the next one as well, which is going to be 6c3. It's going to turn to x cube, and 3 by x square cube as well, plus we don't need any more. Okay, so 4x cube minus 5. Over here, what do we get? 6c1 times 3, which is 18, plus 18 x5 by 2, that's x cube, plus 135, no x there. 6c3 is 20. This is going to be x cube by x6, which is x cube down below. So 6c3 times 3 cube, that is 540. Okay, so that is 540 by x cube, and we don't need any more. So to get the term that is, devoid of, independent of x, what do we need to do? We need to multiply this with 135 and 4x cube with this over here. So coefficient, or the term independent of x equals to 4 times 540 plus minus 5 times 135. 1485. That is 1485. Awesome. That is the correct answer. Just check the mark scheme. Okay, moving on to question 5. The function f is defined by this. State the value of f minus 1. Okay. How much is it? Minus 2 plus 1 divided by minus 2 minus 1. So it's 1 by 3. Great. Diagram shows fx. Sketch f inverse x. Okay. So what will it be? Basically, it's a reflection on the graph, or on the line y is equal to fx, right? There you go. So everything will be inverted. Like, check this point. This is 0 minus 1. So 0 minus 1 turns into minus 1 0. Okay, there you go. 0 minus 1 turns into minus 1 0. That's an important point. And look at this one. This is like minus 4, maybe 0.8ish, minus 4.8ish. So it's going to turn into 0.8. This is 1. 0.8 minus 4. Something like this. 0.8 minus 4. Okay. So yeah, at minus 3, it's like 0.7ish. -3 it's like 0.7ish. At -2 it's a little less like that. Okay, at -1 it's like 0.3ish. At -1 it's like 0.3, something like this basically. And look at this point. At -0.5 it's 0. At -0.5 it's 0. So at 0 it should be like 0.5, essentially like this. And what about this end point over here? As you can see, let's get rid of this point, it's creating confusions. So here it's like maybe it's like, how much is it? 0.3ish, 0.3 minus 4. So at -4 it should be 0.3ish. Like, I'm just inverting everything. Okay, that is the general idea. So it's at -3 it's 0.2ish, so just a little bit less, then a little bit less over here. So that's the general idea. So let's draw the graph now. I think we can do it because we have all the points. This is a very key point, this point over here. Sorry, it's so hard to draw on this tab. God damn it. There you go. There you go. There you go. Basically this. Alright. This is the general idea of the graph. Find an expression for f inverse x. So we know that fx is 2x plus 1 divided by 2x minus 1. So the general idea is we have to let fx be y. So y is equal to 2x plus 1 and 2x minus 1. So 2xy minus y is equal to 2x plus 1. And then what do we do? 2xy minus twice x equals to 1 plus y. Then we take x. 2y minus 2 is equal to 1 plus y. Or x equals to 1 plus y divided by 2y minus 2. Therefore, f inverse x equals to 1 plus x divided by 2x minus 2. Alright. So that's that. Oh, there's another thing. In the mirror line, they should intersect, which it does over here, okay? They should intersect on the mirror line. That's an important point. Anyway, so yeah, we do end up with this, which is 1 plus x divided by 2x minus 2 or 2x minus 1, same thing. Now, what about the domain? State the domain. The domain of this will be the range of this one. So, look at the range of the original one. It's less than half, right? So, if you apply half, what happens here? 2 into half plus 1. 2 into half minus 1. 2 divided by, it's an asymptote. So what's the asymptote actually? If we apply a very small value, like this is 0.5, right? So maybe apply 0.499, 0.499, try it. 2 into 0.499 plus 1 divided by 2 into 0.499 minus 1. Two into 0.499 plus 1 divided by 2 into 0.499 minus 1. It's minus 999 essentially. So where does half actually lie? Where does x half lie? X, this is x1. So x half actually lies here. So at half it's like minus 999. So as you can clearly see, the asymptote is this line. The value y is equal to 1. Because if you try a very low value of x, because it goes to infinity, on this side it goes to infinity, right? At half, look, it can't even touch half. That is one asymptote clearly. And on the other hand, the other asymptote is this value over here, which is y is equal to 1, because try a very negative value like minus 1000. Try it. 2 into minus 1000 plus 1, and then 2 into minus 1000 minus 1. What value do you get? You are getting 0.999, so it can never touch 1. So the range of this will actually always be below 1. It's less than 1. The range is always less than 1. So we can say that the range of fx is always less than 1. So the domain of f inverse x will also be less than 1. So that's how we figured it out. Okay. And for this, since the domain is less than half, the range of this will be less than half. Okay, that's the general idea. For 5b, the function g is defined by this. For all real numbers, gx is 3x plus 2. So find this out. Fx is equal to gf1 by 4. So we know that fx is this. So let's do that. Fx is equal to this, right? So you can write fx is equal to, if you input f into g, okay, so gfx, what will gfx be? 3 times 2x plus 1 divided by 2x minus 1, 2x plus 1 divided by 2x minus 1 plus 2, and we can input gf 1 by 4, sorry, 3 into 2 times 1 by 4 plus 1, 2 times 1 by 4 minus 1 plus 2, half plus 1, half minus 1 plus 2. So 0.5 plus 1 divided by 0.5 minus 1 into 3 plus 2, which is minus 7 actually. So we get this value. So 2x plus 1 is equal to minus 14x plus 7. 16x is equal to 6. X is equal to 6 by 16 actually, which is 3 by 8. This should be the answer. Let me just check the mark scheme. Yes, it is. Let's continue with number 6. Circular measure. There are 10 questions in total in the paper. We will be done soon. Diagram shows the metal plate OAB CDEF consisting of sectors of 2 circles, each with center O. The radii of sectors AOB and EOF are R. The radius of sector COD is 2R. Angle AOB is equal to angle EOF is equal to theta radians, and angle COD is 2 pi. Sorry, 2 theta radians. It is given that the perimeter of the plate is 14 centimeters and the area is 10. Okay. So perimeter. This plus this. This is R, so this must be R as well. And this. Okay, so we have 2 R's, then this one will be R theta. EF is equal to AB is equal to R theta. Okay, this is R theta, this is R theta. What will this be? CD, S is equal to R theta. So 2R times 2 theta, which is basically 4 theta. And this one should be R, this one should be R. So perimeter is equal to R plus R theta plus R plus 4 theta. Wait, it's 4R theta, right? My bad. Okay, plus R again, plus R theta, plus R again. That's the perimeter. And it is actually equal to 14. They mentioned that it's 14. So we can write 4R plus 6R theta. 1, 2, 3, 4. 1, 2, 3 is equal to 14. Okay, so that's that. And 2R plus 3R theta is equal to 7. That's 1. Now let's go for the area. It's half R squared theta. The area for this will be half R squared theta. The same will be for that. And for this one, it should be half into 2R squared into 2 theta. So area is equal to half R squared theta into 2 plus half into 2R whole square into 2 theta. So we are actually getting R squared theta plus 4R squared theta. So that is 5R squared theta. Okay, that's great. 5R squared theta. Great. And the value of the area is 10. So we can basically write that this is 2 is equal to R squared theta. So these are our two equations. So 2r plus 3r theta is equal to 7. So we can actually take r common. 2 plus 3 theta is equal to 7. Okay, so r is basically 7 by 2 plus 3 theta. And on this side, 2 is equal to r square, which is 7 divided by 2 plus 3 theta whole square into theta. If you do the cross multiplication, 2 into 2 plus 3 theta whole square is equal to 49 theta, or 2 into 4 plus 12 theta plus 9 theta square is equal to 49 theta. Then 8 plus 24 theta plus 18 theta square is equal to 49 theta. So if you bring it to one side, 18 theta square, 24 minus 49, which is minus 25 theta plus 8 is equal to 0. So let's just use our calculator. Okay, 18 minus 25 and 8. So what are we getting? I'm just gonna check. So one of them is 8 by 9, the other is theta is half. Okay, so 9 theta minus 8 and 2 theta minus 1 is equal to 0. So theta is equal to 8 by 9 or half, but they mentioned something here. The theta is less than 3 by 4, less than 0.75. 8 by 9 is greater than 0.75. Okay, so this cannot be the answer since theta is less than 3 by 4. So theta is equal to half. So what about r? R is equal to 7 divided by 2 plus 3 into half. So it's 7 divided by 2 plus 3 into 0.5, which is 2. So that is it. These are our answers. R is 2 and theta is equal to half. It was a tricky question. You just need to get the algebra right. Okay, moving on to number 7. Last 4 questions of the day. By completing the squares, find the coordinates of the vertex of the graph. All right, the max point, since it's a maximum graph. So I'm taking minus 2 common, so we actually end up with x square minus 4x minus 11 by 2. Then more steps, x whole square minus 2 times x, the other one should be 2. Then we get plus 2 square minus 2 square minus 11 by 2. So now we can write this as x minus 2 whole square, okay, and then minus 4 minus 11 by 2, that's minus 19 by 2. And finally minus 2 x minus 2 whole square plus 19. That should be it. So what is the maximum point? X minus 2 equals to 0, so it's 2, 19. This is the maximum point or the vertex of the graph. The graph shows part of the curve with equation this and the line with equation this. Find the area of the shaded region. All right, so area of the shaded region is basically calculus integration. We have to find the limits first though, like where do they intersect. So y is equal to 8x plus 9. I'm just gonna input this over here. Should it be easier if I solve it this way? I'm not sure actually. I'll just go for minus twice x squared plus 8x plus 11. So bring it to this side. Oh, we can actually get rid of this. So 2x squared plus 9 minus 11 equals to 0. 2x squared minus 2 equals to 0, 2. X squared minus 1 equals to 0. Oh, so x equal to plus minus 1. So this is plus 1, this is minus 1. Great. Now let's find out the area. So the area should be the one above minus the one below. So curve minus line, and limits should be 1 minus 1. So curve. Do I do it this way? Okay, never mind actually. Minus 2x squared plus 8x plus 11 minus 8x minus 9 dx. Minus 2x squared, we get rid of this, plus 2 dx. Fine, awesome. So integrated. Minus 2x cubed by 3 plus twice x. Good. So minus 2 1 cubed by 3 plus 2 into 1 plus 2 into minus 1 cubed by 3 minus 2 into minus 1. Okay, this is our area. So it's going to be minus 2 by 3 plus 2 minus 2 by 3. Okay, and this is going to be plus 2. So minus 2 by 3 minus 2 by 3 plus 4, which is 8 by 3. 8 by 3 should be our answer. Either this or 2 whole 2 by 3, anything works, we are good to go. Okay, so till now I got all the answers correct, so it's looking pretty good. Moving on to 8, last 3 questions of the day. 8, 9 and 10. Remember to subscribe to the channel, guys, if you like the content, and please feel free to join the mock exams and the revision classes starting from February if you're in Bangladesh or an international student. Trust me, don't miss out on this. Really huge chance to get your desired grade, because you get to learn from the GOAT himself. So yeah, that's that. So moving on to question 8. The equation of a circle is this. Express it in the completing squares form. Okay, so come on, I'll teach you a technique. So x square plus px. Okay, x square plus px. And over here we have y square plus 2y is equal to minus q. Fine. Where a is to be given in terms of p and r is to be given in terms of p and q. Fine. Okay, so let's do this. So essentially completing squares, right? So y square plus 2y, what is this essentially? Is basically 2 times y times 1 square minus 1 square. So we need a minus 1 square on the right hand side as well. That's the logic. And for this one, it is basically p times x. What we need is a 2. Okay, we need a 2 or else it won't happen. What we need is to convert this px into a completing squares. We need a 2 over here, and then to edit this, we also have an x over here. We need a p by 2. Okay, that's the general idea, because I need the 2 there to get the x plus 1 or x plus something whole square format essentially. Okay, now the general idea is they also want something weird. They want the minus signs in between, which is a bit hard to do. They want the minus signs in between, so we have to do something else. Okay, and sorry about this, it should have been a plus sign over here. You can't really change this. Okay, you can't really do that. So let's see what happens. So the general idea is, since they want a minus sign, we have to make some edits. We have to convert this to minus p by 2. Then we get the minus sign over there. And we can't have that, so we need a minus sign over here as well, because this minus minus gives us a plus, which is the original one. Okay, so I'll just show this in another step. It will be easier for you guys. Initially we had this x square plus p times x, and over here we had plus y square plus 2y, and on this side we had a minus q. So the things I added were, I added a 2 over here, so I needed to give a 2 down below. And to make this thing negative, I had to make the starting negative as well. These are the things I added over here. Are we clear? Okay. Now, the next thing that I'm going to add is actually, what we're going to do is plus, to convert it to, this form, x minus a whole square. What do we need? This whole square as well. Minus p by 2 whole square. And since I added it on the left hand side, I also need to add it on the right hand side, which is minus p by 2 whole square. This is the hard sum actually. Okay, I added this on the right hand side. Awesome. Now what about this part? So I'm gonna break this down for you guys again, this part. So 2y, I have a 2 already, I have a y, so what is the other one going to be? It's going to be 1, but we have the same scenario over here. There's a minus sign over here. So to convert this to a minus sign, right, I need to give a minus 1 whole square over here, or else just a minus 1 over here, sorry, or else it won't be plus. And what do I have on this side? Since we have a minus 1 here to balance things, right, to make it plus 1, we need a minus 1 whole square on this side. Okay, so I'm gonna break this down again, and on the right hand side, what do we need? Another minus 1 whole square, like that. So breaking it down, I brought the x's together, y's together, and the q on the right hand side. That's step 1. Now I need the completing squares format. So what did I do? I added a 2 here, so I need to add a 2 down below, right? But since we need a minus sign, I made this a minus sign, and this is a minus as well, because we know that minus minus is plus. And after adding those, I just input this, I just squared this on the right hand side. But since I added 1 on the right, I need to add on the left, I need to add 1 on the right side of the equation as well. Same concept here. We have a 2, we have a y, so we just need a 1, then the format is maintained. But since it's a minus sign, I made this minus, so this should be minus, and this squared should be on the right hand side. And then, as you can see, guys, since I added this on the left, this should be on the right as well. All right, okay. Now it's very straightforward. Let's just go for it. So it's just going to be x minus p by 2 whole square plus, same thing over here, y minus 1 whole square is equal to minus q, this turns into plus 1, okay? And you can change this to p square by 4. They, in the mark scheme, they just kept it as this minus p by 2 whole square, okay? But yeah, this is the end result. So r square is basically this whole thing, okay? So the difficult part was actually this thing over here. So we can actually write a few things now. Check this. We can actually write that. Look at a. What is a? A is basically minus half p. B is basically minus 1, okay? That's that. And r is basically this whole thing combined. Now the line with equation x plus 2y is equal to 10 is a tangent to the circle at point A. So if this is the circle, this is the point 4, 3, and this line is a tangent at that point. Find the equation of the normal to the circle at point A, okay? So let's find out the gradient. 2y is equal to 10 minus x, or sorry, 2y is equal to minus x plus 10, y is equal to minus half x plus 5. So the gradient of the tangent is equal to minus half, so the gradient of the normal negative reciprocal should be plus 2. So now let's find out the equation of the normal. Y minus 3 is equal to 2x minus 4. So y minus 3 is equal to twice x minus 8, or y is equal to twice x minus 5. This is the equation of the normal, twice x minus 5. Good, guys. Moving to the next part, find the values of p and q. Okay, so hear me out. The logic is, we know that this is a point A, and we found out the normal, the equation of the normal, and we know that the normal actually passes through the center. That's one information that we know of. Okay, so this is our center. What is the center basically? If you invert it, okay, if you invert it, like these coordinates are the centers, you know, this is the center, minus half p and minus 1. This is our center. Okay, so what we can do is, we know the coordinates of the center, minus half p minus 1, and we know the equation of the normal as well, y is equal to 2x minus 5. So we know that this will be satisfied by this equation, 2 into minus half p minus 5. So minus 1 is equal to minus p minus 5, or p is equal to minus 5 plus 1, which is minus 4. So we got p is equal to minus 4. Very straightforward. We just input it into the normal. Okay, now for the last 3 marks, we now know the coordinates of P. P is -4. So we can find out the coordinates of the center. -half into -4. How much is that? 2. So the coordinates are actually 2 and -1. 2 and -1. Okay. Now we can find out the radius of the circle. So let's find out radius. So the radius will actually be 3 plus 1 whole square. This is the value of r square basically. 3 plus 1 whole square plus 4 minus 2 whole square. This is the value of r square. I found it out using the value of P. So we know that this is the value of r square. Good. And on the other hand, we also know that r square is equal to this thing over here. Okay. R square is equal to this. So let's simplify r square. So r square is basically 4 square plus 2 square. So r square is equal to 16 plus 4, which is 20. So this is basically equal to 20. And we know the value of P, right? So we can write this that minus q plus 1 plus minus into -4. That's 4 by 2. 4 by 2 whole square is equal to 20. Okay. So hopefully you understand my working, guys. Hopefully I could simplify. So minus q plus 1 plus 2 square is equal to 20. Minus q plus 1 plus 4 equals to 20. Minus q is equal to 20 minus 5, which is 15. So q is equal to minus 15. So that is the final answer, and it matches. Okay. So a tricky sum indeed. The trick actually lies in part 1. If you can do part 1 easily, you can easily find out the normal by finding out the gradient of the tangent and the negative reciprocal. Then just input the points in y minus y1 is equal to m x minus x1, and then just input the coordinates of the center in the equation of the normal to find out the value of P, followed by finding out the radius using your newfound coordinates using a and the center to get the value of r square and equate r square with the equation on top that you had, and then you're gonna get the value of Q. So that's how you do it. Tricky question, yeah? Next. The equation of a curve is y is equal to half k square x square minus 2kx plus 2. The equation of a line is this, where k and p are constants. It is given that one of the points of intersection of the curve and line has coordinates this. Find the values of k and p and find the other point of intersection. Okay. So kx plus p is actually intersecting with half k square x square minus 2kx plus 2. And we know one of the coordinates, which is 5 by 2 and half. So k times 5 by 2 plus p is equal to half into k square into 5 by 2 square minus 2k into 5 by 2 plus 2. Okay. So we can get rid of this one over here. So 5 by 2k plus p is equal to 25 by 8 k square minus 5k plus 2. Okay. So this is what we end up with. If you put things on one side, on the right hand side, 25 by 8 k square minus 5 by 2, which is minus 15 by 2, minus 15 by 2 k plus 2 minus p is equal to 0. This is one equation. And then we know that this actually, works for both equations. Okay. So one of the equations is y is equal to kx plus p. So we can simply write half is equal to 5 by 2 k plus p. If you multiply everything by 2, 1 is equal to 5k plus 2p. This is another equation. Okay. And on the other hand, this one over here, this should work out since there's no p. We know that y, okay, let me use another color. We know that y is equal to half k square x square minus 2kx plus 2. So if you just input the values of half over here and half into k square into 5 by 2 square minus 2 into k into 5 by 2 plus 2. So what do we get actually? We actually did this on top, same working. Half is equal to 25 by 8 k square minus 5k plus 2. You can solve this actually now. Okay, so if you bring everything to the right, 25 by 8k square minus 5k and 2 minus 0.5, that gives you 3 by 2. Multiply everything by 8, so 25k square minus 5 into 8 is 40. We know that 40k plus 4 3 is 12 is equal to 0. So let's solve this using our calculator. 25 minus 40 and 12. Okay. (25) minus 40 and 12. So I'm getting one is 6 by 5, the other is 2 by 5. So let's write like this: 5k minus 6, and the other one is 5k minus 2 is equal to 0. So k is actually 6 by 5 or 2 by 5. Can we accept both? Yeah, because there are two coordinates. Find the values of k and p. Okay. Oh no, they said that it's between 0 and 1. Okay, so it can be this. So k has to be 2 by 5. Okay, we reject the other one. And now we can easily find out p. How? 1 is equal to 5 into 2 by 5, right? Plus 2p. So 2p plus 2 is equal to 1. 2p is equal to minus 1. P is equal to minus half. Okay, they said nothing about k, about p, so this is okay. So that's that. We have the answers of p and k. Now we're gonna find out the coordinates of the other point of intersection. Okay, using this part over here. So this part was supposed to be done later. No problem, no problem. Let me just do this for you guys over here. And this is the second part. And now we are gonna go for the last part. Okay, great, all good. Now the last part, we're just gonna input the values of k, which is 2 by 5. So 25 by 8 into 2 by 5 whole square minus 15 by 2 into 2 by 5 plus 2 minus p, which is 2 plus half, okay, is equal to 0. So let's do this. 2 by 5 whole square into 25 by 8, which is half, minus this is basically 3 plus 2.5, which is 5 by 2. Wait, oh, okay, so we can't use this actually because I need an x, right? So why can't we use this? Because I already used one of the coordinates of x, which is 5 by 2. So this is a no-go. Okay, instead what we're gonna do is we are gonna use the first line again. So it's kx plus p. So 2 by 5x plus p, which is minus half, is equal to half into 2 by 5 square x square minus 2 into 2 by 5 into x plus 2. So 2 by 5x minus half is equal to, let's do this, 2 by 5 square into 0.5, which is 2 by 25. 2 by 25x square minus 4 by 5x plus 2. So let's multiply everything by 25. So 25 into 2 by 5, that is 10. 10x minus 25 by 2 is equal to 2x square, 5 into 4, 20, minus 20x plus 50. So 50 plus 25 by 2, that is 125 by 2. 10x is equal to 2x square minus 20x plus 125 by 2. Multiply everything by 2 now. 20x is equal to 4x square minus 40x plus 125. Okay, so let's bring everything to the right. 4x square minus 60x plus 125 equals to 0. Okay, so 4 minus wait, polynomial is 2. 4 minus 60 and 125. So twice x minus 25, that's 1. and 2x minus 5 is equal to 0. Therefore x is equal to 25 by 2 and x is equal to 5 by 2. Do we just need the x coordinate or coordinates? So 5 by 2 is the first one, so 25 by 2 is the other one. So let's just find out y using this. Y is equal to kx plus p. Y is equal to kx plus p. So y is equal to, k was 2 by 5, right? Yeah, 2 by 5 into 25 by 2 plus p, which is minus half. So y is equal to 5 minus half, which is 9 by 2. So the coordinates are 25 by 2 and 9 by 2 for the other one. Yeah, 25 by 2 and 9 by 2. I guess we are right. Yes. Now it is given that instead that the line and curve do not intersect. Find the possible values of p. The line and curve do not intersect. Okay, so same equation, this one. Okay, same equation. We are going to use the same equation, but here we do not know the values of k and p, and they do not intersect. Previously they intersected, so the goal is to bring everything to one side. Let's do that. So half k square x square, it should be minus 3kx, then plus 2 minus p is equal to 0. So since they don't intersect, we know that the roots are imaginary, so b square minus 4ac should be less than 0. So b square, which is minus 3k square minus 4 into half k square, and c should be 2 minus p is less than 0. So 9kx square minus 2k square times 2 minus p is less than 0. 9kx square minus 4kx square plus 2k square p is less than 0. 5k square plus 2k square p is less than 0. So we have this. Okay, now what? Let's check. So we can take k square common. K square 5 plus 2p is less than 0, so we can ignore k square. So 5 plus 2p is less than 0, 2p is less than minus 5, p is less than minus 5 by 2. That is the answer for p. Okay, that's it. Last one, number 10. The function f with domain x greater than 0 is such that f prime x is equal to this. It's given that the curve has equation this. Okay, find the equation of the normal to the curve at point 0. So let's find this out first. 8 minus 10, 1 to the power 2 by 3. There's 8, 2 minus 3, this minus 10. Okay, minus 1 to the power 1 by 3 into 8 minus 10, that's minus 18. That's the gradient of the tangent. So why so less space? So normal should be plus 1 by 18, then the equation of the normal. Y minus 0 equals to 1 by 18 x minus 1. So 18y is equal to x minus 1. Yeah, that's it. 18y is equal to x minus 1 should be... Oh, did they just want the... Yeah, this is it. You should write this. They wrote it in such a bad way, honestly speaking. Okay, this is... So find fx. So we need to integrate f prime x to find out fx. Okay, so integration of 8 twice x minus 3 to the power 1 by 3 minus 10x to the power 2 by 3 dx. Let's do this. So it's going to be 8 2x minus 3 1 by 3 plus 1, that's 4 by 3, 4 by 3, and below we are going to have 2 into 4 by 3. Okay, and here it's minus 10x, 2 by 3 plus 1 is 5 by 3, down below 5 by 3 plus c. So this is basically fx. Okay, so fx is equal to 8 into twice x minus 3 to the power 4 by 3 divided by 8 by 3, and this is going to be 30 by 5 x to the power 5 by 3 plus c. So after simplification, we can get rid of this. So fx is equal to 3 times 2x minus 3 to the power 4 by 3 minus 6x to the power 5 by 3 plus c. We have some coordinates, right? 1 0. Okay, so 1 0 0 is equal to 3. 2 times 1 minus 3 to the power 4 by 3 minus 6 1 to the power 5 by 3 plus c. So 0 is equal to 3. 2 minus 3 to the power 4 by 3 minus 6 plus c. 0 is equal to 3 1 minus 1 to the power 4 by 3 minus 6 plus c. Minus 1 to the power 4 by 3 into 3 minus 6. So 0 is equal to minus 3 plus c. C is equal to plus 3. There you go, you got 1, you got the value of c. So for fx, let's write down fx, the expression for fx. It should just be like this. 3 twice x minus 3 to the power 4 by 3 minus 6 x to the power 5 by 3 and plus 3. So let's check with the mark scheme. 3 times twice x minus 3 to the power 4 by 3 minus 6 x to the power 5 by 3 plus 3. Perfect. Okay, pretty glad that I solved the paper perfectly till now. There were no mistakes. It is given that this equation can be expressed in this form. Determine making your reasoning clear whether f is an increasing function, a decreasing function, or neither. So to be an increasing function, fx or f prime x, sorry, the first derivative dy by dx or f prime x has to be greater than 0. Okay. So let's check the domain. It is given that the domain is greater than 0. That's the main idea. So let's try doing this. For all values of, the domain is x is greater than 0. So if you input any value that is positive, let's see what happens to the value of f prime x. We saw that it was negative over here, right? We can't input 0. So it's a 3 mark question, so we have to answer accordingly. So let's try doing this. This is fx but just expanded. Okay, this is fx, f prime x, sorry, but expanded, and we also have fx over here. Okay, we also have fx over here, and if you differentiate this, you will get this. So since we have the equation of the gradient, we can actually find out its determinant, which is b square minus 4ac. See what I'm doing? So minus 128 whole square minus 4 into 125 into 192. Let's do that. Let's see the value. Minus 128 whole square minus 4 into 125 into 192. It's minus 79616. So you can write, since b square minus 4ac is less than 0, what does that indicate? What does this indicate? It indicates that the roots are imaginary, or the gradient is never 0, because this graph actually never touches the x-axis, and it's a minimum curve, right? So what does it mean that the roots are imaginary? The curve lies like this. This is the general idea. Okay, the curve lies like this because the roots are imaginary, it never touches the x-axis, and in this context, since it's the graph for the gradient, it means that dy by dx is actually never zero. Okay, and the logic is, since it is always below the x-axis, how did I figure this out? It's a minimum curve and never touches the x-axis, so it has to be down below. It is always negative, so it's actually a decreasing function. So you need to ensure that, you need to say that it is a decreasing function because f prime x is actually less than 0 for all positive values of x, or for x is greater than 0 according to the domain in the question that's given. Okay, it is always negative because it never touches the x-axis according to the determinant. Okay, and there was another extra point that you needed to say. That extra point was that there are no turning points. There are no turning points in the original function. What does the original function actually refer to? This one, the function that you found out. There are no turning points here. How did we figure that out actually? Because look, if you equate dy by dx with 0, what does the turning point mean? That the curve goes like this and this. At that point, dy by dx becomes equal to 0. So at one point it was an increasing function. After the turning point, it becomes decreasing function. So it's really essential to say that there are no turning points. How did we figure that out? Like if you equate this with 0, this is very important. Okay, for x is greater than 0, of course, you would get no turning points. Look, if you equate f prime x with 0, what do we get? 8 to x minus 3 to the power 1 by 3. Or basically this, if you equate this with 0, try doing it. This is that equation essentially, right? If you try doing it, you will actually get imaginary solutions. 125 on your calculator, minus 128, 192. The roots are imaginary. What does that mean? It is never 0. Okay, since the determinant is less than 0, it is imaginary. That means it never touches 0. And what does that mean? Since dy by dx is never 0, that means there are no turning points. So since the determinant is less than 0, roots are imaginary. So there are no turning points because dy by dx can never be 0. Okay, and since it's a minimum curve, it will always be negative because it is always less than 0, because it's a minimum curve which lies below the x-axis. This was a very complicated and tricky question. So guys, that was it. Hopefully I could clarify every question over here and simplify things for you. I heard that this was a hard paper, and yes, it was. The first part in circles and the last part in functions, and overall the paper was a bit tricky. So hopefully I could break things down. If I made any mistakes, please comment down below, and I'll be solving more math papers, physics, chemistry and bio every day of the week. I'll be launching more for your May June 2025 exams. If you like the video, remember to subscribe to the channel, like this video, and if you're interested, please do join the mock batches and the revision batches, the crash course, where we will compress the syllabus in a very short way so that you can secure your grade. A quick shout out to my top tier patron for the month, Nigel. He's been supporting me on Patreon. We have one-on-one meetings every month, so if you guys want to be featured on the end screen or get one-on-one meetings with me or get my notes, consider supporting me on Patreon. All of the solved papers are available there with working. Anyway, that's been it, guys. I will link the paper for October-November 2024, paper 1-1 up here, and the paper for October-November 2024, 1-3 down here, and the playlist for pure math paper 1 up there. And remember to hit the subscribe button. See you guys. Bye bye.